Good morning, everybody. So this is a continuation of a review for chapter 9.1, which is stoichiometry. I said on my last video that we're going to complicate things a little bit, and we've gotten to that point. So once again, I've said it numerous times, we're now taking chapter 7.2 and chapter 8 and using it in chapter 9. Some of you are still struggling with chapter 7.2. It's just going to be a snowball effect for you that's going to get worse and worse, especially when we get to our new content next week in chapter 9.2. So we're still doing stoichiometry. Mass to mass is going to be the #1 stoichiometry conversion we use. I'm not saying you're never going to see the others again, but typically mass to mass is pretty common. So now we're taking, like I said, chapter 7.2, where you first have to effectively write the equation. Then we're using chapter 8, balancing, and then once those two steps are done, now you can actually do the math to math. So there's always going to be 2 steps before you can actually do math to math. If you get either of those steps wrong, it's not going to be a good thing for you. Okay, so first thing we have to do is write the chemical equation from the written equation. So you're ignoring the stoichiometry, which is the 1 gram, the question mark grams. You're ignoring that right now. First, write the chemical equation correctly using all of your rules. Check for diatomic elements, check charges if necessary, watch out for prefixes, and I'll try to point out a couple of things here and there as I work through these. So go ahead and do that, pause the video, balance it when you're done, and then do the stoichiometry. Okay, so we have fluorine, which is capital F. Watch your symbols. Fluorine is not FL or anything like that. Also, fluorine is diatomic. If you don't know that, look at your periodic table. You should have them highlighted. Hydrogen, and then nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So you have to give it a little 2 subscript. Fluorine plus hydrogen oxide. I'm just writing the symbols first. Well, I guess I'll write the symbols first. Yields ozone, which I told you is O3, plus hydrogen fluoride. Okay, step 1, write the symbols. Step 2, I don't remember if it's check charges or check for diatomic. I'll say check for diatomic. F by itself is diatomic, so I put a 2. Okay, oxygen is usually diatomic by itself, but I'm telling you ozone is O3, 3 oxygen. Okay, then check your charges. You do not have to check the charge if an element's by itself. Okay, if it's by itself, there's no charge. The only thing you have to check for is it diatomic. If it's a compound, make sure you check your charges. Some of you are forgetting to do that. Hydrogen is +1, oxygen is -2. Got those from my periodic table. If you don't know where those came from, go back and watch 7.2 video. Ozone doesn't need to check any charges, it's by itself. And then hydrogen is +1, fluorine is -1. Okay, so when I crisscross these, I then put this 2 down here. And that 1 goes there technically, but I don't write it. So I now get H2O from the crossing. Some of you are dropping them straight down. You have to crisscross them. Okay, so now you can balance. I'm going to erase my charges and you need to show these guys. Okay, some of you aren't showing the charges. It says on the worksheets, show the charges work. Show them. I'm just erasing them so we're moving on. I don't have to rewrite it. Okay, now I'm balancing. I've got fluorine, hydrogen, and oxygen. I have to split them up. You don't have to make a list, but some of you, I think it helps. Feel free to. 2, 2, and 1 on the left. 1, 1, and 3 on the right. Okay, what would you like to start with? Anybody? Anybody? Did I hear someone say H? Okay, we'll start with H. I'm going to put a 2 here. That balances those. Now I got to worry about my oxygen. Put a 3 over here. That also changes my H to 6. So that means I have to go back here and change this. I got to erase. Can always erase coefficients. All right, then I got 6 H's on the left. I need 6 on the right. That also changes my F. write 6, 6, 6, 6, 3, 3. So my final answer is, for balancing, 3, 3, 1, 6. And please write it this way. Okay, I don't want to see commas. I'm sorry if you learned it that way. I don't want commas. You don't need to put the yield arrow in there. Okay, you're just writing what's on these lines. 1, 2, 3, 4 lines, 4 numbers. Some of you are forgetting numbers. Make sure you write it. I'm trying to help you out now, but these are things you should already know. Start fixing them. All right, so now I've got it balanced. Now I can actually do the stoichiometry. So up in my problem, my word problem, I had 1 gram of fluorine, so I'm going to rewrite that under here. And I had question mark grams of hydrogen fluoride. Okay, so now I can actually start the stoichiometry. So my known is fluorine, 1 gram of F2. Don't forget your unit gram label, which is the element or compound. Mass to mass, so 1 mole of fluorine always goes on the top, 1 mole of your known over the molar mass of fluorine. Well, I have, I'll do it up here. Oh, whoops, sorry guys. I have, do it up here. I'll do it down here so I don't click it by accident. I've got 2 F's. Fluorine on the periodic table, its atomic mass is 18.998. I'm going to round it to 19. So 2 times 19 gives me 38. So my molar mass of F2 is 38 grams per mole, which mole's up here. I know it's confusing, but you don't need to write moles down here. Okay? Then my mole ratio, which comes from the balanced coefficients. My unknown coefficient, whoops, I meant mole. I'm just going to turn this into it now. Unknown coefficient with a unit and label over my known coefficient with a unit and label. It's the mole ratio, so the units are moles. And then the last part, I'm going to multiply by the molar mass of the unknown divided by 1 mole of the unknown. So 1H, 1F. H is about 1 if you round, you don't have to. F is, like I said, about 19. Add those together, and you get 20, or whatever you got that's close. Okay, so check. Grams of F2 cancels out grams of F2. Moles of F2 cancels out moles of F2. Moles of HF cancels moles of HF. I'm left with grams of HF, and that's what I'm solving for. So plug that into your calculator. 1 times 1 divided by 38 times 6 divided by 3 times 20 divided by 1. And I got 1.05 grams of HF. If your number is very close, that's fine. You may not have exactly the same decimal, but it should be pretty close. Okay, so like I said, chapter 7.2, chapter 8, chapter 9. Make sure you know how to do it all. If you mess up one, you mess up the next, you mess up the next. Snowball's out of control. And I will say, not many people are coming to my office hours. There's a lot of you that I think would benefit from it because I think you do have questions, or you're not turning in assignments, or you're not getting great scores on your assignments. Come to the office hours every day, 10 to 10:45. And if you have a class that overlaps, then chat me and we can figure out a different time that works for you. But a lot of people are just coming, asking a couple questions, and then leaving, or hanging out to hear other people's questions, or some people are just coming, asking a question, and then staying on and just doing work. Whatever work. Some people are doing calculus work, some people are doing history, algebra, I don't care. Get your chemistry done, and then if you want to just hang out on the video, that's fine. All right, second example. So the first thing you have to do is write out the chemical equation, then balance it, and then stoichiometry. So pause the video, try that. All right, so writing the symbols first. I've got aluminum plus iron oxide. I'm not worrying about charges or diatomic right now. Yields aluminum oxide plus iron. Okay, the one thing I saw last week, yes, I know aluminum has a +3 charge. That doesn't mean it gets a subscript of 3, it's just Al. Okay, iron, some of you are getting this wrong. Iron's charge is right there. If it gives you a Roman numeral, I'm telling you to use that Roman numeral for your charge. Do not look at the periodic table. So iron's +3. And oxygen is -2. Okay, so now that I've written my charges, I'm going to crisscross them. So the 2 comes down here, the 3 goes over. So you write the charges on top, but then you crisscross them if it doesn't equal, because 3 times a -2 is overall -6, and 3 times a 2 is overall +6, and now they do cancel. So that's why you have to do that. Okay, and then come over here. Aluminum is a +3 charge. Oxygen is a -2, so once again I crisscross those, so it becomes Al2O3. And then iron's by itself, so it doesn't need anything. Doesn't matter what the charge is, it doesn't get anything. Okay, so I'm going to erase my charges. You need to show them on your work. I'm going to erase them just to keep this clean. And then we'll begin balancing. So you have to split everything up into elements. Aluminum, iron, oxygen, 1, 2, 3, and then 2, 3, 1. Nope, that's wrong. 2, 1, 3. Okay, take whatever you want to start with. Save oxygen for last, because it's already balanced at this point. Put a 2 here. 2 here. Check. 2 aluminum, 2 aluminum, 2 iron, 2 iron, 3 oxygen, 3 oxygen. So my balancing is 2, 1. Whoops. I am not doing well with the pen today. 2, 1, 1, 2. Okay. Now you can actually start the point of this, which is stoichiometry. And get used to this because you're going to be doing it for a while once we move on to new content. All right, so I'm going to take this 44 grams and put it back under aluminum. I'm going to take this question mark iron and put it back under there. Now I can do the mass to mass. My known is aluminum. 1 mole goes on the top with the unit and label. It's only 1 aluminum, so that's equal to the atomic mass, which is 26.981. I'm going to round to 27, but you don't have to. Some people like to round everything, some people don't. Pick your poison, doesn't matter. Okay, coefficient of my unknown is 2 with the unit and label. Don't miss all those silly points by not putting units and labels. Coefficient of my known is also 2. And then I'm going to put 1 mole of my unknown on the bottom as a constant. And then I have 1 iron, so that's equal to the atomic mass, which is 55.8 something. So I'm going to go 56. And before I even do the math, I always check and make sure my units cancel. Grams of aluminum, moles of aluminum, moles of aluminum, moles of iron, and lots of grams of iron, and that's what I'm supposed to be solving for. So in your calculator, 44 times 1 divided by 27 times 2 divided by 2 times 56 divided by 1, and I got about 91.3 grams of iron. So as long as your number's close, you're good to go. The only way you're going to get the exact same number as me is if you round exactly like I do, which could be possible, but you don't have to round exactly like I do. All right, try another. If you think you know what you're doing, skip ahead, try a harder one. Oh, this is a good one. So now I have a word problem. So make sure you try these ones because you're going to have to do these for your worksheet this week and once we get to 9.2. Okay, this is where you have to understand chemistry. You have to understand products and reactants. Reactants are your starting ingredients. They're to the left of the arrow. Products are your end results, what you get. They're to the right of the arrow. So how many grams of oxygen is produced, yielded, that's my arrow, from a reaction of 100 grams of mercury 2 oxide decomposing into mercury and oxygen? Okay, so what is my reactant? Mercury oxide. So I'm just going to rewrite this for you guys. You don't have to write this out. Mercury 2 oxide decomposes, that's my yield, breaks down, into, what are my products? Mercury and plus sign, whoops, sorry, clicked it again with my hand, and oxygen. That's my equation. how many grams of oxygen is produced from a reaction of 100 grams of mercury 2 oxide. Okay, so once again, write the equation out first. Mercury, Hg, oxide O, yields decomposes into mercury plus oxygen. Diatomic elements. Oxygen is diatomic when it's by itself, so it gets a subscript of 2. Checking of charges. Well, I have mercury 2 oxide, so the charge of mercury is 2 from the Roman numeral. Oxide is -2, so I don't have to crisscross there. And since mercury is by itself, we don't touch it. Okay, so that's the first step. Write the written equation. Now you need to balance it. Split everything up. Pretty easy one. Okay, so my final answer for my coefficients is 2, 2, 1. Now I can actually start the stoich. Just cleaning up for you guys. You don't have to erase all this or necessarily rewrite it over and over again unless you want to. Okay, so it says, how many grams of oxygen was produced from 100 grams of mercury oxide? So mass to mass stoich. 100 grams of mercury oxide, 1 mole of my known over the molar mass. So 1 mercury is about 201, if you round. 1 oxygen is about 16, so I get 217. You might have something a little bit different if you didn't round that way, which is fine. Mole ratio, unknown coefficient over known coefficient. And then 1 mole of my unknown. Molar mass of my unknown, I have 2 oxygens at 16 each, gives me 32. Shocking, I'm going to check. Grams of mercury oxide, cancels out grams of mercury oxide. Moles of mercury oxide, cancels out moles of the same. Moles of oxygen, cancels out moles of oxygen, and I'm finding grams of oxygen. So, in your calculator, 100 times 1 divided by 217 times 1 divided by 2 times 32 divided by 1. I got 7.37 with a unit and a label. You could have a little bit different number, but you should still have 7 point something. Don't just give me 7. Also, don't go 7.4. That's lazy. Go at least 2 decimals. Actually, go 2 decimals. I really don't want any more. And the only way I want less is if there isn't a second decimal. All right, try another word problem. These are what you really need to understand. How many grams of hydrogen nitrate are produced from the reaction of potassium nitrate and 83.2 grams of hydrogen sulfate? The other product is potassium sulfate. So how many grams are produced? That means hydrogen nitrate is a product from the reaction of potassium nitrate and hydrogen sulfate. So potassium nitrate, like I said, you don't have to write this unless you want to. Potassium nitrate and hydrogen sulfate are my reactants. How many grams of hydrogen nitrate are produced? So hydrogen nitrate is a product, or yes, it's a product. And then it says, sorry about that. The other, that's nitrate. The other product is potassium sulfate. Okay? And you can do this if you want. If that helps you to write it like that and then write the formula, go for it. All right, potassium nitrate. Watch you not having nitrate. Plus hydrogen sulfate, not sulfite, not sulfide, yields hydrogen nitrate plus potassium sulfate. Okay. Check diatomic elements, check charges. Well, I don't have any diatomic elements because I don't have any elements by themselves. So moving on to charges. I got lots of charges to check. No prefix, I'm checking all the charges. So I've got, oops, I'm in highlighter. +1, -1, +1, -2, +1, -1, +1, -2. So crisscrossing them, nothing here. HBH2, SO4, nothing here, and then K2, SO4. Okay, so now you can balance. You can separate everything out, KNOHS, or you can leave your radicals whole. And if you like to, you can always put parentheses around your radicals to make it even easier to kind of stick out to you. I'm going to leave the radicals whole. Okay, I'm going to start with my K's. Go to my H's, which also fixes my NO3. So my final answer, 2, 1, 2, 1. I can start my stoichiometry. That's why you guys have to really pay attention. If you would have, messed something up here, if you want to check these charges and had H, you just had HSO4, it's going to mess up your balancing. I'm not saying you can't balance it. I mean, you shouldn't be able to. But you may have a balance, but doesn't mean it's right. And the stoichiometry is going to be wrong. You're going to be sad. Okay. How many grams of potassium nitrate, or how many grams of hydrogen nitrate? And then there's 83.2 grams of potassium nitrate. Word problem, just like math. You got to figure it out. All right. Mass to mass. The molar mass of potassium nitrate. Let me look at my notes. Okay, you have one H, one N, and 3 O's. Altogether, you should get about 63 for your molar mass. Okay, then I've got my mole ratio, unknown coefficient, unit and label, over known. And then all I need now is the molar mass of my unknown. So I've got, whoops. Wait, am I good? Oops. I messed this up, guys, sorry. Sorry, I was copying my notes wrong. That goes here. Hopefully you caught that and you're like, what the heck is she doing? That's my unknown molar mass. My known molar mass, I have 1K, 1N, 3 O's. Oh my gosh, this whole problem I did wrong. Have you guys been thinking this the entire time and you keep watching me? Yeah. All right, hold on. It's Friday, it's 2:28. My eyeballs hurt from looking at a computer. And I'm losing my mind. Shocking, I know. Okay, sorry guys. I'm so sorry that you just wasted a couple of minutes. Here's what's wrong. It's 83.2 grams of hydrogen sulfate. It goes right here. I had the wrong known. So sorry if you were trying to tell me that the entire time I was yapping to you. Try this again. Okay, my known is H2SO4. So my molar mass is wrong. I have 2 H's, 1 S, 4 O's. So H is about 1. Sulfur, I usually round it to like 32. Oxygen, 16. Add those all together, you get about 98. So my 1 mole of my known goes on top. Molar mass of my correct known now. Jeez. Okay. See, even teachers make mistakes. Nobody's perfect. All right, now let's try it out. Grams of H2SO4 cancels out grams of H2SO4. Moles of it cancels out moles of it. Moles of HNO3 cancels out moles of HNO3. In your calculator, 83.2 times 1 divided by 98 times 2 divided by 1 times 63 divided by 1. I got about 106.97. If you got something of 107 point something, rounding. My unit is grams, and my label was HNO3 hydrogen nitrate. Whew, that was a rough one. Just to redeem myself, one more. I'll get this one right. How many grams of magnesium phosphate are produced from the reaction of 25 grams of potassium phosphate and magnesium chloride? The other product is potassium chloride. All right, we got this one. Pause your video, work it out. All right, blah, 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 are produced from the reaction of 25 grams of potassium, which is K, phosphate, not phosphate, PO4, and plus sign, magnesium chloride. The other product is potassium chloride, so that's one of my products. And here's my other product. How many grams of are produced? Produced means product. Okay. Step 1. Step 2, check for diatomic elements. There aren't any elements by themselves. Step 3, check charges. Potassium is +1. Phosphate is -3, so I have to crisscross those. Becomes K3PO4. Magnesium's +2. Chlorine's -1. Crisscross those. I get MgCl2. Potassium +1. Chlorine -1. Nothing to do there. And magnesium +2. Phosphate -3. Becomes Mg3 parenthesis PO4 parenthesis 2. Okay, balancing, you can split up your radical, but I'm gonna leave it whole. K, PO4, Mg, and Cl. If you're still not sure how to leave your radicals whole, come to office hours or Zoom me and I'll show you. Makes your life so much easier. All right, start with whatever you want. I'm gonna throw a 3 here. Now my chlorine's way off, that's okay. Because I'm gonna fix it right now. Remember, you don't have to do it in the same order I do it. It's all about just getting to the same answer. How to erase a coefficient. Done. My final answer for balancing is 2, 3, 6, 1. Also, watch you guys are simplifying. If you got 4, 6, 12, 2, those are all divisible by 2. Simplify it. All right. Stoich. I'm going to do it right this time, I promise. Just cleaning it up so we don't get confused. All right. 25 grams of potassium phosphate. Here is potassium phosphate. Got it. Check. How many grams of magnesium phosphate? I don't know. How many? Okay. Also, it doesn't matter. Your question mark can be on the left and your number on the right. It's whatever. It doesn't matter the order. Still mass to mass. All right. 25 grams. potassium phosphate. Molar mass of that, actually correct this time, 3 potassium, 1 phosphorus, 4 oxygen. Potassium about 39, phosphorus about 31, oxygen about 16. This is really the only time you can say about in chemistry. About 112 for my molar mass. Mole ratio, unknown over known. And molar mass of my unknown, make sure you distribute inside of the parentheses. I've got 3 magnesium, 2 phosphorus, and 8 oxygen. Magnesium's about 24. We said phosphorus about 31, oxygen about 16. I got about 262. Okay, if you have something a little bit different. Okay, don't forget units and labels. Grams of potassium phosphate cancels out grams of potassium phosphate. Moles of it cancels out moles of it. Moles of magnesium phosphate cancels out moles of magnesium phosphate. We're left with grams. That's what we're looking for. Ready? 25 times 1 divided by 212 times 1 divided by 2 times 262 divided by 1. I got about 15.4. Should be pretty close. Okay? So I know you're saying, oh my gosh, can she please be done with examples? If you've actually watched this and tried them, congratulations, you're doing what you're supposed to be doing. If you haven't watched it, I guess you're never going to hear me say this. Boo for you. If you just watched it to watch it, but you didn't actually listen or try, also boo for you, because you're only hurting yourself, and I can't tell if you watched it anyway, to be quite honest, but you know what I can tell? In your work. You either know it or you don't. If you know it, you probably watched this and tried it yourself. All right, so that's the end of Chem 1 review. The next video that you see next week will be, wait a second, what did I just say? That is the end of Chem 1 review. The next time you hear my voice, will officially be Chem 2. All right, guys, talk to you later. Come to office hours if you need me. Chat me, whatever you gotta do.